So that yes, it's optional. Actually, for this class, it's virtual instruction, so it's optional. It's up to you. You don't have to join virtually, or you can watch the recording video. It's up to you. But from my point of view, I prefer you guys to join me on the virtual instruction here, because when I'm the teacher, when I'm the instructor, I prefer to have the kind of the interaction here, right? Interaction. So it's not face-to-face interaction, but when I have online interaction from you, I think it's easier for you and for me to run this class.
Yeah, my advisor said that this course is better with a virtual classroom than entirely just online. So, yeah.
Okay. So any one of you, if you are not speaking, you please mute the phone, so it's not impact the other one. Whenever I'm not talking, please mute the phone.
Yeah, let me. You can also do a push to talk.
So let me review about the chapter 1. The chapter 1 is actually chapter 0 in the book, everything about the computer, the component of the computer, right? So basically, you remember, for every computer, you have the kind of, you have the input. You have the system unit. I don't know why. And you have output here. Okay, so can you name some of the input device you have?
Keyboard.
Yes.
Mouse.
Yeah. Everything takes the data from the end user. Here it can be a keyboard, can be mouse, can be scanner, something like that. And for the system,
touch screen, game controller, MIDI controller.
Yeah, right. So when we move to the system unit, what do you have? What do you have in the system unit here?
Processor.
Yes, the brain of the CPU, right? Sorry, the brain of the computer, right? Central processor unit here. And anything else?
RAM.
You have RAM.
Some kind of storage.
Yes, it's storage, right? And you have ROM also, right? So what's the difference between the RAM and ROM here?
ROM is read-only memory.
Yes.
So I guess ROM's a bit more like storage, whereas RAM is random access memory, which is sort of more like the short-term memory. It's where the computer keeps the things that like need to be accessed in the moment, I guess.
Yes, right. It's correct. Yeah. So think about when working with the word processing, when you open the file. So actually, normally, if you want to permanently save the file, you have to store it into the hard disk drive or SSD or something like that, right? But whenever you click the file, actually it load into the RAM, and the reason that it loading into the RAM, because the RAM is work way faster when compared to the HDD here, right? And the RAM is only temporary. That's why whenever you reload the computer, or whenever you power on, everything gone. So that's why if you want to save it, you only have to save it to the permanent storage here. So for the storage, you can have the hard disk drive here, or you can have the SD, or you can have the optical kind of the CD or VCD. And nowadays, a lot of you is very flexible when you save it in the cloud in computer here, right? So you can save in the Google Drive. So providing that you have the internet connection, you can access to the data anywhere, anytime here. And the ROM is a read-only memory. It's normally about the control of the hardware. So normally when you power on the computer, that it have to make sure that the hardware, everything working smoothly here.
So ROM's for the stuff that the computer's like always using.
Yes. So normally it's during the startup, it only control the hardware here. It normally works in the startup process. Right. And for the output, you have something about the screen, right? You have the speaker, you have the printer, something like that. Okay. So now we move to the software. You have the software. Move to the software, break it down into two categories here. The first one, you have application. You have application software here. And the second one, you have system software. Okay, so application software normally it have to enhance the productivity of the program, right? Thinking about you have word processing, you have image processing, something like that. And for the system system software, everything about the control the hardware of the computer and interface with the end user here. So for the system, you can think about Windows, you can think of Mac OS or Linux here, right? So what in one hand, it controls the hardware of the computer, and in the other hand, it interface with the end user here. And when we're talking about the programming language, right? Programming language, again, for the programming language, again, they break it down into major categories here. So if you remember about the programming language, they break it down into the low level, right? The low level here. And the high level. So in the low level, again, they break it down into two major groups here. Do you remember what are they? For the low level.
Low level's kind of like just like binary, isn't it? Just like pretty much just like code that's like harder to understand.
So like machine code then?
Yes, right. So in the low level, yes, you are correct. Both of you are correct. So the first one is the machine, right? The machine language here. The machine language actually is everything about the 0 and 1, because you need to see underlie of every computer, it's only working with the binary system. And when working the binary system, everything about the 0 and 1, right? So when working the machine learning here, actually it work everything with 0 and 1. So in order to do with the machine learning here, sorry, machine code here, you have to totally understand about the hardware, right? So we think you have to, it's very, very specific hardware. So we think about you have to deeply understand about the hardware. And the one thing about the machine coding here, it works very fast because you don't have to translate it. You don't have to compile it into the machine language, because everything already working with 1 and 0 already, right? So it's working very, very fast. But the disadvantage is that it's very hard for you to do it, because you have to totally understand about the hardware, and it's very, very hardware specific. And one more thing, when working with the machine machine here, it is hardware specific. So when you coding with one computer here, you cannot bring it to the other computer, because you see each computer they have specific hardware. So think about, you have different keyboard, you have different ROM and RAM here. You cannot move from the one computer to other computer here. Right? So that is the machine language. They have the advantage, work very fast. Work very fast because you don't have to take time to translate it. You don't have to take time to compile it here, and you don't have to. They don't use a lot of resources because you don't have to translate it here. But in the other hand, it's very hard to understand, and it's very, very hardware specific here. That is machine, and the second one you have the assembly here, right? The second one you have assembly here. So assembly is a little bit improvement from the machine coding here. So instead of working in 0 and 1, they group some of the 0 and 1 together into the character here. So a little bit of the improvement for you to understanding. And that's why for assembly here, you have to, again, you have to translate it. They call it as assembly to translate it to the machine language here. And so for the high level, again, they break it down into major group here. The first one you have to do is the compiling here, right? Compiling. The second one you have interpreting here. So can you tell what is the difference between the compiling and the interpreting here?
if I'm not mistaken, I think like compiled like languages, like they need to like actually be pre-compiled before they're able to run on a machine, whereas like an interpretive language that kind of goes like line by line. It's a little more like
yes.
Python or even basic.
Yes, right. So for the compiling, actually user need to compile for one time only. So when it's compiled to one time, it kind of executable file. So you are able to run it again and again and again from the computer to computer here. You just do it one time, right? And for interpreting, it's line by line. So every time you need the interaction, you need the input from the end user here. Okay.
So when something's compiled, and again, I'm sorry I wasn't here yesterday, but I always kind of assume when something was compiled, that means it sort of translates it into like machine code. But if machine code only runs on one specific hardware, then that doesn't sound right. Because like if you compiled it on one machine, then like so how am I getting ahead of everyone here?
Okay, go ahead. So actually for the compiling, you just do it one time. Right? So one time, and whenever you execute it, that means you have double click about, say you have an exe here, right? Exe file here. Actually, the compiling is only one time again, only one time. And when you have the exe here, when you double click it, actually that's the time you have to interact with the hardware here, and you make kind of the command, you send it to the hardware here.
All right.
So it's not hardware specific, right? Actually,
okay.
Yeah, okay. So now we move to the second one. You move to the third one. You have the software development lifecycle, right? So basically, if you remember about the software development lifecycle, you have the 4 steps here. You have 4 steps. The first one, you have analyze. I don't know. My pen is very not okay. You have the analyze problem. What happened with my pen? You have design. And you have coding. And you have testing here. It is a software development lifecycle, right? So when we talk about the software development lifecycle, so we think about the cycle. That means for every step, you are able to go back to make the modification here. I think about that. You are able to do some modification here. So for every project, you also have at least 4 steps here. You need to analyze, you need to design, you need to the code, and you need to do with the testing here. So it's a testing that make sure that you have something that you expected here, right? And for analyze here, normally you do everything about the input. You have to identify what is the output, right? What is the output and what's the input here. Sorry, my pen isn't. I need to fix it. I have another pen here, but I'm not able to find it. Okay, so about analyzing, you have to identify what is the output, what are the output, and what are the input here. So can you tell from where can you find the output and from where can you find the input here?
So analyzing the problem.
Yes.
The I don't know. I guess like the input would be.
So basically, the output is you have to identify what are the expected, right? What are the expected output here? So we think about if you want to make a project, if you want to make some cookies, right? So the first thing you always have to know what do you want from this one, right? So the first one, think about the example that you want to make some cookies. So the output here are the cookies. You know that the output here is the output cookie, and you want to make some cookie. That is the output, right? And the input, that everything you can figure it out from the output. So when you know that, you need to make some cookies. So you have to figure it out what are the input you need in order to make the cookies here. So if you think about, you want to make 10 cookies, something like that, right? So you have to figure out that you need something about the flour, you need something about the milk, the egg, sugar, something like that, chocolate chip, right? So the first thing in every step is that you have to tell what are the expected output you want. Right? For this example, that you know that you want to make process 10 cookies, and you have to very specific about the requirement of the output here. So if you want the 10 cookies, what's the size each cookie here? You want it small, or you want it big, or you want to overcook, you want it crunchy, or you want it soft. You have to very specific about the output here, right? And also from the output, you are able to figure out what are the input here. From that, everything about the output and input normally is in the analyze here. And for the design, once you know the output and when you know that what are the input here, you have to design, you have to figure out step by step, you have to figure out instruction here, right? So we think about, you have to list out all of the instruction here. You think about the first one, you have to mix flour, right? Flour. You have to put flour here with the milk. You have to crack the egg, mix them together. You have to mix the sugar, and after that, you have to put on the oven to bake it. Right? So you also have to specify how much time you want to bake it, and depend on the requirement. If you want something crunchy, you have to bake it, say, for 30 minutes. But if you want something soft, you just bake it for 15 minutes, something like that, right? So when you do everything with design here, the coding is very simple. Actually, the coding is very simple. You just stick into the design step by step and do it. Yeah, just do it here. And the last one is testing. So when you take out the cookies, you have to make sure that it's crunchy as you expected here. And if it's too sweet or not enough sugar, you have to fix it, and you have to come back to the analyze or design and do it again. That's why it's a life cycle here. Okay. So in the software development life cycle, you have to remember that analyze and design are the most important step of the life cycle here, because the more specific in analyze, the more specific in design, the more success rate you have when you have the output here. Actually, the coding is very simple. Once you understand about the analyzing, when you are understanding about the design, you just stick into the design and translate it into the programming language. Right? So when you understanding the design, you can apply it to the Java or C++. It doesn't matter. It doesn't matter. Any question for this?
I'm good.
No, not at the moment. No.
Okay, so that just want you to to keep in mind that the two most major important steps is always analyze and design here. Right? So the more specific you are, the more success rate you have. Think about that. If you want to make cookie, you have to very specific about which is the size of the cookies, and if you want to crunchy or soft, or you want to sweet or not, something like that. So you don't want to go back and do it again and again. That's why you very have to very specific in the analyze and design here. Okay, so now I move to this one. On the last class, I will talk about a little bit about the pseudocode, and that to clarify again that pseudocode is not programming language. It kind of the logic computer program and help you in the analyze and the design here. But when you understand the logic of the pseudocode, when you understand the logic, it's very helpful for you to translate it into the specific programming language here. So once you understand the pseudocode of program, you can apply it into the C++ or C#, something like that. And you have some information about the input, the variable, and constant here, right? So input is everything you have to give it to the computer in order to do with the program here, right? And you have to clarify the difference between the variable and constant here. Variable, that means changeable. It's everything about changeable here, and the constant is everything stays the same during the program here. And when you think about the variable, normally each variable they have the specific name. So when you have specific name, normally you have the specific memory slot here. So you think about if you have something about the variable name, say about the balloon here, the same with the I do this last week. So when you declare the balloon variable, actually it only reserves one slot in memory, and the memory here is the name balloon here. So when it variable, whenever you enter it, then the value will be stored in the slot memory here. So whenever you enter the number 10, it is stored in the variable name balloon here. So the next time, if you enter the number 20, it will override the number 10 and it stores the number 20 here. Right? So think about the variable, it is changeable and it is one slot in memory and it's overriding here. Okay.
Well,
yes.
I've always just seen it as like a variable in algebra, you know, just something like a placeholder for a value, like any given value.
Yes. So actually, it depends on the programming language. Some of them they are very specific. So when you declare as an integer, you cannot use that floating or you cannot use that as string here. But some of the programming is very open. So it can be one time it can be string, and one time it can be character, and one time it can be integer here. And it depends on the programming language.
Right.
Okay. So now, if you look on this one example, it is an example of the pseudocode here. So normally for the pseudocode, you have 4 steps. For every programming, you have 4 steps here. The first one is everything about declare variable here. The second one, you have to get the input, right? You have to get the input for that. That's the first one. The third one, everything about calculation. You have calculation, and you have to giving out the output here, everything about calculation. And the last one is that once you already have the output, you have to print it out. I think about this one output here. Okay, so we see if you look on the pseudocode here, you understand the logic. It's very helpful for you to translate it, to apply it into the specific programming here. So you think about this Java, this one is C++. The logic is quite the same here. So when you talk about the data input, normally you have the two steps. The first one is the prompt here. The prompt is everything you gotta tell the end user what you have to do and what you are expected to enter, right? So we think about this one the prompt here. This one prompt. You enter the number of song you wish to download or to purchase today. That one is the prompt here, and it print out on the screen to tell you what you have to do. And the second one, the keyword input here, the song here. So what action? What happened when you have this one? So after you have the prompt here, so if you enter the number 10, so actually it will store the number 10 into the variable name, the song here. That's the thing. That's the thing working with the data input here. And you have you have to understand the difference between the variable and constant here. And the input prompt is a naming variable here. That means the variable name must be one word. No space are allowed. It cannot be starting with the number, and should be meaningful here. That's one is you should pay attention also, because something you just put X, Y, and Z here is not really make sense, and it's very hard for you to follow up your program here. So think about some of the program, it's very complicated here. So the more meaningful you put into variable name, so it very happy for you, easy to follow the program here. Okay, so is something happen, right? So think about once you declare the two variable, the song and the dollar price here. So actually you already have the two variable slot here in the memory. It's a song and dollar price here. So now after the input, if you enter the numbers 78 here, it's stored into the memory of the song here. And after the calculation, after the calculation here. Right? You see after this one. After this step here, so we set. So at the beginning, you see you have two variable name here. So one is the songs, the second one is the dollar price here. Right. At the beginning, you have nothing on that. So after the prompt of the input, if you enter the number 100 here, it's stored into the 100 of the slot with the memory, the song here. Right. So what happened? After the calculation here, you set the dollar price equal to 0.99 times song. What happened here? It reference to the slot with the memory, slot memory with the name of the song. And you know that it take it out, so 100 here. So it replaces this one with 100 and you have 99 for that one. And after this step, you have 99, you assign it for the dollar price. So actually you write down here to the dollar price and you have 99 here. So after this step, you see, you only have the memory slot with the name dollar price and you take the value of 99. And the last step is print it out to tell users that how much money you have to pay by using the keyword right and the dollar price here. Right. Okay, so when remember one thing about the variable, right? The variable changeable. That means you can assign or reassigning value to variable. So if you want to assign the value for variable, you have to use the keyword set also, right? You have number x equal to 45 here. And now if you want to change it, you are able to reassign it again. So we set the number x is just 97 here. So what happened at the beginning? You have the value. You have the one slot with the name of x here. The first time you enter you set it to 45 here. But the next time, if you reassign 97, actually it overrides this one. It's not 45 anymore, but now you have 97 here. And you also already study about the operation and the priority, the order of the operation, right? So we have to do everything. You have to do everything with parentheses first, right? Where I see that already something where here. Yes, you have to do everything with the parentheses. After that, you do with the exponentiation, and after that, you do with the multiplication, division, and modular here. And the last one is everything with the addition and subtraction here. And one thing about the modular, is the remaining of the division. That's one thing you have to remember that. Okay, for the data output, the data output, you know, that's one you will store something after the calculation, right? You will store something in the dollar price here. Memory, and after that, say thinking about 9.9 here. So the last step that you have to take it out, you have to print out to tell the user that how much money you have to pay. Right? So you have to use the keyword here, right? And you have the dollar price. What happened? It reference to the slot memory of the dollar price and it print out the number 9.9 here. Right? But you see, if you print out the number for 9.9 here, it's not really make sense to the end user. Right? It's very hard for him to know what really happening here. So normally you have to annotate the output here. That means you have to put some text into the output to make it more sense, to make it more meaningful here. Okay, so think about this one, right? If you just write the dollar price here, you will print out here 99 here. Sorry, 9.9 here. It not really makes sense. But instead of doing that, you can use the annotate here. You can use a combination of the text here. You can use a combination of the text and the variable here. So what happened? Every text, if you put in the double comma here, it print out exactly the same. Right? So from the screen output, you see everything here. It print out from the text. This one, it's reference to the slot memory dollar price here, and this one, everything is text here. So we see when you compare this one and this one, the second one is make more sense for the end user to follow with here, right? And one thing about when working with the Raptor also, when working the Raptor or pseudocode, you also have you should pay attention for the formatting output. You should use something about the space or exclamation to make it more sense. Right? So we think about this one. Here, you use the text here. And the variable name, the text, variable name, the text, and variable name. And you see the output here. The sum up, it is the text here. Right? The number one, you take the number 8 here. Keeping out the 8 is the text. It's the text here. The number one, no, sorry, number 2 here, and is 14 here, the sum here. So we see if you look on this one, it's not really good formatting, right? So instead of that, you can use a space here. You can use a space here, the space here, the space here, space here. It makes more sense for this one. Right? It looks way, way better when you compare to this one here. Okay, so now we move to the data type here. Sorry, any questions so far? Let me know.
I'm good.
Okay, so you move to the data type. Data type is the amount of space you allocate in the data. It depends on the data type here. So it depends on the data type. Some of them you say you have the integer. So normally it's the integer, or you have the floating. Each of them they require for the specific amount of data. So think about if you have the integer, normally you require 2 bytes. You require 2 bytes in the memory. But if you're using the floating, normally you have to require the 4 bytes or something like that. It depends on the data type of the variable, and it requires for the sum of the specific amount of space in the memory here. And some language, they have the many data types, the integer, the floating point data, string, character, Boolean type, double, and so on. Some have very only few data such as numeric or string here. And some of the language that some of the language, they are strictly type language. That means when you want to use it, you have to declare it. You have to declare it. So when think about you have declare number as integer here. So when it's strictly type, so when you declare as an integer, you cannot use this number here. You cannot use a variable number here as a string or character or floating point anymore, because it's strictly to the integer already. But some of them, they are loosely tied or open here. So when if one time you can use that the integer, at the time you can use that the floating point or character or string, whatever it is. So that is the thing that once you're working in some specific programming language, you have to understand about the logic. You have to understand about the syntax of that when working with the data type here. Okay, so the declare statement, it's when working the pseudocode, you have to use the keyword here. You have to declare, and after that, you have to put the variable name and as here, and you have to specify what data type it is. What data type it is. Okay, and normally for you have some of the basic data type here. The first one is character and string. Character is everything about you see on the keyboard here. So you have character A, character star, something like that. Everything about you see on the keyboard here. Normally everything you see on the keyboard here. But it's not only limited on the keyboard. Some of them is not here in the keyboard. But remember the character is only one character here. It's only one character. And the string you have that means you have the sequence of character here. You have the sequence of character. So we think about I have the hello here. It is string because it have a lot of character here. 1, 2, 3, 4, 5 here. Right? So the difference between the string and the character only one character. And you can see at the keyboard here. And string is a sequence of the character here. And the string, when you think about string, it can be character, but the character cannot be a string here. Right? That's one thing about that. And normally for string or character, you cannot perform any math operation here. Normally you cannot use the division, you cannot use the exponentiation or something like that. The only thing you are able to do is by the concatenation. That means you join them together. You join them together by using the adding here. So think about you have you have string 1 here, you have string 1. String 1 here. So you have the hello, and you have show, you have the word here. Okay, and now you are able to join them together, concatenate them together, and you can use the string 1 plus string 2, you print out the hello word here, something like that. Okay, so if you want to declare the character and string variable, that you as normal, you just use the keyword here, declare. That one is variable name, right? The variable name, and you have to specify it is as, this one is character, and this one is a string here. You always have to specify the data type here. And this one concatenation, you can join 2 strings together, right? You see, if you have first here Lizzie as the last here Duck, and you can set the full name here equal to the first reference to Lizzie here, and you're able to put the space here, and the last here reference to the Duck here. So after this one, you will see the full is the Lizzie, and you have space here, the Duck here. So you already know about the character data type, you know about the string data type, and now we move to the data. So integer here, integer is everything about the positive, negative, or 0, but it must be the whole number here. It must be the whole number. You think about 8 here, it's integer, but 8.3 here is not integer because it's not the whole number here. All right. So actually, this one I can see for here. This is integer. 0 is integer. 4.0 is not integer because it already has the decimal part here. You have 4.0 here. Okay, so declare the integer variable is the same. Very simple. You can use the keyword declare here and variable name, and you use add integer here. Okay. Now we move to the floating point data type. Floating point data type is that you have something, you have both integer part and fractional part here. You can think this one is the integer part and this one fractional part here, right? Something like that. And you can have some of the repeating number. Well, think about when you will take 1, you divide by 3, right? Divide by 3 here. So you have the repeating number, you have the 0.3.3, and go on forever. And you have some of the irrational number. You have the square root of 2, so we have 1.4, a lot of things after that here. And remember one thing about the 7 here is not floating point, but 7.0 is a floating point here. Okay, so again, if you want to declare something with integer or the floating point, you just use the keyword here, declare and the floating in integer, or if you want to declare the character or string here, it's up to you, right? It depends on the data type of this one. And you have the sum of the naming convention already. Try to make it meaningful, and you cannot use the space in the naming here, something like that. Now, that's I think the last one for this one is the Boolean data here. Boolean data, everything about true or not, right? It's a true or false. It's everything black or white here, 1 or 0, true or false, something like that. And the last one you mentioned about the syntax error and the logic error. The syntax error is the program when you're talking about the syntax error, program will not be executed, and normally you have the error notification here. Right? So whenever you have the syntax error, when you want to run the program will be stopped, and we have the error notification here. So think about what's the syntax error. Some of the programming language is very specific. So you have if you set x equal to the y plus z here, and they require you have to put the function here, but somehow you're missing it. It is a syntax error. So when you execute program, when you go to this step here, it tell you we have the notification here that you have missing this one here, and you have to fix it here. But the logic error, program will run it smoothly. You have nothing to do with the programming when it's execution. It runs smoothly, but the output here is not what you expected here. So think about example of the logic error tip about when you want to figure out the area of this rectangle here, and you have the length and you have the width here. Okay, so normally the area will be, if you want to figure out the area of the rectangle, you have the length times width here, right? But somehow, if you make a mistake, instead of length times width, you put the plus here. So when you run program, it runs smoothly. You have nothing to wrong with the program when it's execution here, but the output here is not what you expected here. So if you think about, you have a length it's 20 and the width here 10, and the area, what you expected for area is the 20 times 10 is the 200 here. But somehow if you put the addition here, the length and width, you only have the 30 here. So when you have the print-out program, you have the area is the 30 instead of the 200. But from the program point of view, it runs smoothly. You have nothing. You have no error with the programming when you're running here. Okay. So remember one thing about syntax error: program will not execute it, and you have the error notification. But for the logic error, you have no error notification here, and program will be executed here. The only thing is that the output is not what you expected here. Any question for that?
Nope.
Nope. Good.
Let me see what you have for this graph here. Watch this video.
What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode. English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people one at a time, we instead count them 2 at a time. This algorithm does twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all since there aren't any pairs of people in the room. And so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2. But then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm is said to be buggy because it has a mistake. Let's address some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition, otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, this algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s. But beyond that, it's going to get a little difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
Okay, so this video is about the algorithm, right? Algorithm actually is a list of instructions, and some of them you need to modify, or some of them you need to optimize that to bring the expected output to you here. Let me see what they have for this one. Let's see. So again, if anyone of you is not speaking, please mute the phone here. That was not back to the other one here. So if you look on the module, actually you have a lot of things to reading and to figure it out. But from my point of view, everything I cover in the class here is already enough for you to do with the homework or assignment, and you don't have to take the time to read so many things. Honestly, so many things here. I don't think it's quite relevant, but I have to import it from the shell, from the Ivytech. That's why I had to put it here. But some of them, for me, is not really good. So everything I cover in the class here is already enough for you to do with this class here, to do with the assignment and the homework here. Okay, so now let me review a little bit of the quiz here, what you have for this one. And remember again that for this class, you are required to do you are required to download the Raptor, and you have to install the Raptor to do with the simulation here. Right? So I already have the if you watch on the video on the Tuesday, I have the you can able to see the how to download the Raptor, how to install the Raptor, and in that I have the some of the very basic example when working with the Raptor here. Or you can watch it. You can watch it in the module here. I also integrate it here. So when you click on the reading assignment, sorry, reading assignment here. Yes, so I have a short video. I made it by myself and I upload it in the YouTube. And you can able to see it when working the Raptor here. Very basic. I'll see this one is a pseudocode. Sorry. This one is pseudocode. And
Hey, I have a question.
yes.
Is Raptor a program that only works with Windows?
The Raptor, yes. The Raptor only works in Windows here.
Great. I have a Mac.
So if you have the Mac, you can install the virtual box, right? And you can install Yeah, you can install that window on the virtual mouse, either on Box and download the adapter from that.
I had a question. Is VirtualBox free for students, or is there a free version?
VirtualBox is free.
Free,
I
yeah,
think
totally free. But one thing here, if you want to download the Windows version, you have to use the Ivytech account to download the Windows version image here, and you can use it for free.
Oh, okay.
Let me see where you find the window. You have to download the Windows version image and install on the VirtualBox here. Okay, so now let me work out with some of the quiz and the homework here. Okay, so here's very simple, right? In the statement set number equal to 93. So actually, if you have this one here, right? Then let me see. So actually, after this one, you have the slot here, the number. And after the set number equal to 93, it installs the number 93 into the variable slot, the name number here. Okay, so if you set the number equal to 93, the number is, what do we think? What data type it is?
Numbers an integer variable.
Integer, right? Integer here, the integer. So this one integer. The operator returns the remaining after divide the one number by another.
Is it modulus?
Yeah, modulus, right? So basically, the modulus operator will return the remaining after that one. Data sent by program to the screen printer or file is
Output.
Yeah, the output here. The sequence of characters is
String character?
String here, string character, whatever it is. Any whole number, positive, negative, or zero.
Integer.
Yes. The serial code statement used in the textbook to display the message on screen is
Right.
it's right. Yeah. So you know, if you want to bring it down with the serial code here, you have to use the keyword array statement here. Complete the following statement to declare the variable name money here. Integer.
Money as integer.
Yeah. So the syntax with the serial code, you only have to use the keyword here, declare, right? Declare and variable name and as data type, right? So for this one here, you have the money is the variable here. So we have to put the declare the money, declare money. As this one, they require you to do the integer, right? So we have to put the integer here. A way to develop a program before actually writing the code.
Pseudocode.
Yes, pseudocode. It's a statement declare freezing point at code. So what is the variable name here? What do you think?
Freezing point.
Yes, and what's the type here?
Float.
Yes. In the statement set temperature equal to 32, the value of 32 has been
assigned.
Yeah, right. So whenever we set the temperature equal to 32, actually it assigned to the slot here, right? Assign the value to the slot here. Many programming language include string operation call.
Concatenate?
Concatenation.
Yeah.
I can't pronounce it.
It can
Concatenate.
Yeah,
Concatenate. Okay.
Concatenation or something like that. A string eyes and string scream. So after this one, right, you just concatenate the two strings together. And what is summary you have?
Ice cream, no
Yes.
spaces.
Yeah, right. You have no space here, right? So remember that. When a variable is first assigned a value, it is said to be
Initialized.
yes. That's one thing you have to remember. So at the beginning, if you declare, right, if you declare you have nothing, in the variable here. You just have a one slot memory. But when you assign for the value, it is initialized here. The data is considered board. Symbol file in the type document is known as.
Is it string?
Yes, I think it's in here. A variable can only have one or two possible. This one. What is it?
Boolean.
Boolean, right? Boolean. So true or false, 1 or 0, which is not a way to input the data in program.
Those are all. Those are all
Those
ways.
are all, yeah.
Yes, all of them. What are the what is the value for expression?
2.
2.
Remaining. What's the value of this? You have to do it. Right? Remember that you have to do it in the order of priority. You have to do everything in the parentheses first. After that, exponentiation. After that, division and multiplication from the left to the right. And the last one is everything about the addition and subtraction again from the left to the right here.
I think the answer is. I think the answer is
It's
2.
also 2. Yeah.
Okay. So what is the value of the payday? What do you think? What's the
30.
value?
150.
No, it's 30. Because hours is set to 5.
Oh
Yes.
yeah, sorry, I misread that.
It is override here, right? So you see, you have the hour 5, payday 30, and after that, you see, it will override here. So hour 5 and 6 here. Oh, again, it is 30 here. The rule of the Ivytech programming is the rule. What is the rule here?
Syntax.
Syntax, right? So we remember about everything about the syntax is a rule. So if you have the syntax error, the program will not be executed. And normally you have an error notification here. A Boolean variable can be with the following value.
Any of these.
Yeah, true or false, 0 and 1. With the following would use in the store telephone number. I think string, right?
A string, yeah.
What is the output? Following, okay. What do you think? Which one is
It's
correct?
the first
Yeah, it's the
one,
first
I
one.
think, yeah. There's no space after of.
Yes.
In between of and the print and the
You have no
closing.
space. Yeah, no space.
Quotation.
The first one is the correct one. Of the first step, analyze, right? Like which the following is not.
It's the second one.
Yes.
Starts with a number.
Right, start with a number. Okay. Sorry. This one is your own experience, so I have no way to correct it. So number one, number two, number three, you already mentioned on the class, right? That's one. Number 4 and 5 here, you are supposed to do with the pseudocode here. You are to do with the pseudocode for the challenge number 2 and the challenge number 5. So let me see what are they. Right. Where number 2, number 5. Okay, so here's a challenge, right? So we have the right program that computes and displays the 5%, 15% chip when price of milk is input by the user. Okay, this is the following variable here. Okay, now think about this one here. All right, number 2 here, you have the right program that's a compute and display the 15% tip when the price of a meal is input by the user. Okay, so that thing about you working with a program, you have the 4 steps here. You have the analyze, you have the design, you have the coding, and you have the testing here. So the first step is always the analyze program, and you have to identify what are the output and what's the input for this one here. Okay, the first thing you always have to raise the question: what is expected output here? What are the expected output here? So for this one, what do you think? What is the thing that you want to do? Sorry, what is the thing you want here? What is the expected output here?
The final price.
Oh, really?
Which one?
The number 2 here. The number 2 you see is the number 2 here.
So yeah, the output would be the input multiplied by 1.15.
No, I'm asking about what is expected output here. That's all. You don't have to explain how to do it. The first thing you will have to raise the question: what is expected output for this one?
Oh, how much you're gonna tip?
Yes, that's a tip already, right? Because you see, you require to display the 15% tip here, right? So the expected output as a tip is the tip here. And in order to figure it out, what is the tip? What do you think? What is the input here?
The price of the meal.
Yeah, meal price. You have to use the meal price here, right? The meal price here. So we see for this one, the price simple. You have one output, it's a tip. And in order to figure out how much is the tip, you have to know what is the meal price here. Okay, so we know that for this one, you need the 2 variables. So the first thing you have to declare, these two variables here. So you think about this one, right? You think we come back to this one. The first step in the pseudocode here, you have to declare here. You have the output here, it's a tip. Input here is the meal price. As what? What is the data type here? What do you think? What is the data type?
Probably a float.
Float, right? You can have a 115 or something like that. It's not always integer. That's why you look on this one. They require the float here. That float, right? Okay, so now the first step, it already declares the variable use. What is the second step? What do you think? In the pseudocode.
Maybe make another variable to hold the percentage of the tip.
Now let me open the here. This one, right? So think about the first one is always declare the variable use. The second one, you need to get the input. Right? You need to get the input. You have to use a prompt here to tell user that what he have to enter here. Right? So for this one, you have the keyword, right? And you put the keyword input here. So for this one, you have to write here. Enter your meal price, something like that. Meal price. Okay, that one is a prompt, right? It print out on the screen to tell that user that what you have to do. After this one, you have to use the keyword here, input, and you have to put the meal price. Right? So what happened is this step. Actually, at this step here, you will have one slot here. So one slot is the milk price here, right? Milk price. And it depends on you. If you enter the number 100 or 250, it means store the value here, 250 here, something like that, into the variable name milk price, right? So now you already declare the variable use, you already have the input, everything about the calculation, right? Every program you have the, for every program you always have the 3 steps here. Sorry, the 3. So you just remember, for every program you always have the input. You have calculation, processing. Actually, it's a processing. And after that, you have output. Okay. So now we see you already have the input. Now to do the next one is the processing. And remember, every processing you have to use the keyword as set here. All right. Set what? You have to set the tip here equal to what? What do you think? Equal to milk price, right? Milk price. Time what? Time percent, and you have 0.15 here. That one is a constant. It's always 50% as a 50% here. That's the one constant here. So you see, after this step, you have the slot memory, the tip here, and it depends on how much you have to pay for milk price. It will get out the tip from the milk price here, right? So something like that. So after that, you restore something in that. The last one is that print out to the screen to tell the user that how much tip here you have to pay. Right? So in order to do that, you use the keyword here, right? You have to pay. What do you think? You have to pay here the type, right? And what do you think you have to pay? What is it?
Well, first put a space after pay.
Yes, and
then you have to pay meal price plus tip.
You have to pay I think the output here is only the tip, right? I think that
just the wording you have to pay. I thought that meant like the total, but yeah. So if you're just going for the tip, then we just add the variable tip.
Yes, right. So that one is that you have to pay for the tip here, and this one the variable tip, and it depends on how much money you pay for the meal price. You have the appropriate the tip here, right? So think about, if you pay here 100, the tip here is a 15, right? If you pay the 200, the tip here is a 30, something like that. And this one is variable, that's why it's changeable. That's why when you print out, you have to put the tip here into the variable into the output here. Okay. Now move to the next one, number 5 here. Right, program display investment of total interest. Okay. Now, if you look on this one, right, what do you think? Let me see what is the output here. In total interest and final value. Okay. So now, if you look on the challenge file here, what do you think? The first thing here, you have to identify what is expected output here. What is expected output for the number 5? What they require, right? In order to figure out what are the expected output, you look on the program statement here, and you have see that what do they require to do. So what do you think? What are the output here?
The amount of interest you make?
Yes, that's the first one. And
the final value?
Yeah, so actually for this one, you have 2 outputs here. The first one is the investment total interest. The second one is the final value, right? You have the 2 output here. Now you look on this one. They set here, interest here. Where is the interest here? You have the interest here, and the final value. They are the output here. So in order to figure out what is interest, what is the final value, you need something in the input here. You need something in the input. In order to do that, you need the principal, you need the rate, and you need the time here. all of them, they are the input here, right? So remember integer and final value here, they are output, and final rate and time, they are input here. And each of them, they have specific data type here. You see integer float, final value float, principal float, but time here integer, right? And you also have the sum formula here. Okay, so now let me do this one here by working with this one. Right. The first one you have declare here, right? Now you have to declare every variable you use in this program here. Right? So if you look on this one, you have the 1, you have 2, you have 3, 4, and 5, and you have 1, 2, 3, 4 of them in the float here. That's why you have to declare the integer, principal, rate, and final value as float. Right? So declare integer, rate, final value. What is this? Final value, principal, right? Sorry. And what else? What do you think? You also have to declare time, right? But the time here is not float, it is at integer here, because you can think about 1 month, 2 months, or 3 months, or something like that. Okay, so one thing about this one here, you have to pay attention when you're working with the pseudocode or real programming here. Once you use the variable name, you must be consistent with that one. You always have to must be consistent with this one here. So we think about when you use the integer here, but somehow when working with calculation, you put the number 1 here. It's not correct. It's not the same. Right? So once you declare the variable and when you use it in the program, you must always be consistent to use the same name variable here. Okay, so the first step is declare already. What is the second step here? What do you think? You have to tell the user to get the input, right? You have to enter the what is now let me highlight what is the here. So you have the rate, you have the value final value, and sorry, you have the rate, you have integer here. You have rate, you have integer, and principal. They are input, right? And no, sorry. Integer is output. So you have rate, you have principal, and the time. They are input. You have to ask user to enter what is the rate, what is the principal, and what's the time. And after that, you have to do everything with calculation to figure it out what is integer and what is the final value here. Okay, so now you already identify that you need the 3 input for this one. So you have to use the keyword, right? You have to use the keyword here to do the prompt here, right? Enter the principal, is that, right? Enter the principal. Now you have to use the keyword input principal here. Okay, and remember one thing, you always have to consistent with this one here. You have the principal, sorry, principal here. This value here, this variable here must be the same with the name of this one. It always have to be consistent with this one. Now the first one principal, and you can do the same with the rate, right? The rate here. Right. Now you can do the same with time, right? Enter the time. Okay, so if you look on this one, actually what happened here? So when you declare all of the variable, actually you have all of the slot memory is this one, right? You have the integer here. You have the rate here. You have the final value here. You have the principal here. I have the principal. And you have time here. Okay, so you have the principal here, input. You have the rate here, input, and you have time here, input. So what happened? If you, after the prompt, enter the principal and you input the principal, say you enter the number 100 here, it will store the number 100 in this one. All right. Now, after this, you write enter the rate and input the rate. So if you input the rate, say about 10%, you have the 10 here, store in the rate variable. All right. That's the last one, enter the time. So you enter for 1 year, you have the number 1 here. All right. That's all. You see the input already have the value here. The next one, everything about the calculation, processing. Right? So in order to do processing, you have to use the keyword set here. And if you look on this one, you see you have the formula here, integrate here equal to something like that. You can copy it. It doesn't matter. Right? And you have another formula here. You have final value. This one, right? So remember, you always have to use the keyword set here to do everything with the calculation here. Okay. So now, what happened? You have interest here. You set interest in equal to principal, time rate, time here. So rate here, I think 10% it should be the. Don't have any. Okay, this one. But if you have a 10%, it can be the 0.1 here. Sorry. My pen is not able to erase it. So now, so we do everything with calculation. The last one, what do you think? What's the last thing here you have to do? What's the last thing here?
Print the output, like string saying, you know,
yes,
the final value is, and then final value variable.
Yes. So you see, after the calculation here, you already figured out what is intensity. You already have something here stored in the interest memory slot, and you will have the final value here is stored in the variable. So the last thing you just take it out and print it out to the end user, right? So in order to do that, you have to use the keyword right here, and your interest here is, and that one is take, and you have to alternate it with the variable, right? You have to pull it out what is interest right here, and you have to write it down here is variable name interest here. Okay, and you do the same. You do the same with the final value here. So you just change it here. And this one, you just redirect it to the final value here, and the variable name here is not interest, but it is a final value. And one thing about you, just remember that you must be consistent with variable name here. So if you have the capital V here in this one, you also have to use a capital V here in this one. Otherwise, it's not the same here. You got it?
Yes.
Okay.
Yep.
So any question from you? Let me know.
Good.
Okay. So I think that's all for this week. It's very simple for this week here. And so next week, I believe that you have something to do with the Raptor. It's more interesting when working with the Raptor here. But that's all for this week. And if you have any question, let me know. And remember that I have the office hour. I made it in the announcement here. So if you need any help from me, you can go to the Zoom meeting on the office hour, or you can send me email anytime. You don't have to wait until the office hour if you need my help here. Okay. Any other question? Let me know. Any question from you?
Nope.
Okay.
Nope.
Good.
Okay. So if you don't have any question, we can end the class for today, and I see you guys on next Tuesday here. Okay. Bye, guys.
All right. See you next week.
Thanks. Have a good
See
one.
ya.
Thank you.